What's up? This is Brian. I am back. And we're going to do some more physics. It's 11.3. Hopefully you've looked at it. It's this guy right here. And you probably have it in front of you. You're probably like, how the freak do I do this one? Well, guess what? I'm going to show you. Alright, first things first, we're going to draw. We love to draw stuff. So we're going to draw this. You know, one of these days I'm going to get better at drawing. And it's going to be great. Let's see how much room we have. Oh, there's no room up there. Great, sweet. So we've got this guy, and essentially we know that this angle, I think that's what they give you. Well, for me, remember we call it angles, these angles theta, 29.3. And this is the T that we're looking for, because it stands for tension. Remember this 5.6 kgs, Kevin Garnett's, for those of you who follow basketball, it's a joke. 17.8, but yeah, basketball's fun. NBA, what's up? So okay, we got force 1, force 2. Now what I'm just doing is pretty much what you guys should do, and it's just to draw it out. If you don't see it, it makes the problem a lot harder. Some people do it in their heads, and they're just smarter. Okay, so we've got that. And what we want to do is first solve for t. Obviously, that's what they ask. So, if we're looking at the diagram, we've got it's kind of messy, but what we're going to do, like we did in the last problem, is called the sum of torques. And what is that equal to? Well, we know that if we just look at all our torques and we pick a pivot point, we're going to pick this as the pivot point, and we're going to go M1 times G, and that's the first mass, or excuse me, the first force, and we're going to multiply that by L divided by 2. Remember, the force and whatever it's pushing down divided by where it's located compared to the pivot point. So M1G is, we'll call it this guy, and then he is always, remember that it's always going down at the center of, if there's like a bar or something like that, it's always the center of the bar that's pushing down. So that's why you have to do L, and L is right here. L. That's the length. Alright, next is M2G, and that's our next mass, times L, and that's mass 2 times the length, the whole, I think you guys can see that. Whoops, sorry. That's a minus sign. Let's erase that. I love this program. Gone. Minus T sine L. Now you ask, what the heck is T sine L? T sine is essentially the same thing as Ty. In this, we're looking at it in torques, right? So we know these torques are pushing down, but there's also another torque that's pushing up, and it's from this tension. But we divide this up into what we call Ty and Tx. You probably remember this from, or something similar to this, from forces and how forces work and how you can divide them up, and vectors and all that fun stuff. So we know that this bottom part is pushing down, but this Ty is pushing up. So that torque is pushing up, and that's why you have to do T sine of L. You essentially know that T sine of L is this theta is equal to this theta, And if you, we can do it all out real quick if you guys want to see it. So you've got sine of theta. Whoops, I even forgot the theta there. Sine of theta. I like singing it. Theta equals opposite, which is ty over t. You bring the t up there, and you solve for ty equals sine of, oh gosh, I am all over the place tonight, times t equals ty. So you just put sine t times L. I hope you guys got that. If you don't, you can yell at me, you can write all kinds of stuff online, and that's fine. So we got these added up. So mg L divided by 2, mg2, or m2g times L. And then, so these torques, and then this torque. Remember, this torque is your t of y pushing up, and it's sine theta equals ty over t, which is equal to sine theta t equals ty. Alright, cool. So, and that's minus, or subtracting it, because it's going the opposite direction. Alright, so the next part of this is essentially just factoring out. We know it equals 0, it's sitting still. So what we can do is really just, well, we can factor out all the L's. So we got L2 M1G plus L M2G, and then I'm going to bring this to the other side, kind of skip a step, sorry, we got to get going on this. Oops. T sine theta, I'm going to put this L on this other side. So what we can do is divide this side by L, divide this side by L. And these L's cancel. Well, essentially you have to do that and that. It's algebra, right? And what you get in the end, these L's cancel, boom, 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 whoops, boom. And then remember, L over 2 divided by L is essentially 1 over L. Multiply, L's cancel, you get 1/2. Fun little trick, eh? Okay, so we get 1 over 2 M1G plus M2G equals T sine of theta. I hope you guys are following. I know it's getting kind of messy. This is a longer problem, so I apologize. Actually, I shouldn't be apologizing because it's a long problem. So essentially we just plug and chug, because we know M1, or we know this, and we know sine of theta. And so we just solve for t. So all we're doing is dividing this side by sine of theta, and I'll erase him, and we get t, right? Easy. So go ahead and do that, and you get an answer. Mine was, so this is part A, was 413. Alright, so part B, let's begin. So B, so what I did for part B, they're asking, what is it? The horizontal force. So we know that, scroll up, oh geez, I did not mean to do that. Oh, look at that. So much nicer. You guys can probably see better too. So the horizontal force is this. Bam. We call this the R of x. The vertical force is the R of y. Now, some people are like, what the heck, why is the vertical force going up? Well, there is, I'm not sure. Ask your teacher. I don't remember. I just know how to do it. So, what we've got is the sum of forces in the x direction. Remember, essentially, anytime you are doing, it's asking for the force. It's like, oh, hey, I want the tension between the cable and the pole, the horizontal and vertical forces. Every time you see forces, all you do is the sum of forces, and it's kind of easy. Well, once you learn it, it becomes easy. So R of x minus, remember, what's opposing R of x? T of x, right up here. So you can't see that. T of x. And it's equal to 0 because they ain't going anywhere. They're standing still, right? So R of x equals T of x, right? Simple. And all you got to do to solve for T of x is pretty easy. Because you've got this theta right here, you know T, you just do some trig. All it is, well, where's T of x at? Sorry. So, yeah, you use the cosine. So use cosine, oh geez, cosine of theta, and theta is just the angle, whatever your angle is, equals adjacent, which is T of x, over T. Remember, you have T right here. And all it is cosine theta times this T. Mine was 413. And my cosine, or my theta was like, what was it, 29.3. So I'm just going to plug it in, and I got 360, about 360. So that's it. B is solved. Easy. C. Next. And it says the sum of forces in the y direction, right? Sum of forces in the y direction, well, there's a few more, remember? But still, if we're just looking at forces, we're not looking at torques. It's just forces. So we'll write these out. M1G plus M2G. Remember, M1G, this guy, 5.6 kgs. Point down, this guy, force 2, pulling down, and then we look at the forces going up, which are minus Ry, right there, and minus, Ty. Well, guess what? We know Ty, we know MG2, or M2G and M1G. And remember, if it's not going anywhere, then it's 0. So all we do is plug in and then bring Ry to that side, and we're good. So essentially you do that one, subtract T of y, and then you get R of y. So it's pretty simple. I got 27. That's it, folks. Hopefully that helped. See ya. Bye.